So today we are going to talk about open source collector that we have built for advanced silicon observability features. And before we present the collector part, I want to take a few minutes to explain the use case here. So the use case is packet drop monitoring, right? Whenever we have packet drops, in a network, which are inevitable, that affects the user experience. And typically, if you follow the traditional model, then usually the user experience is a problem, and then they report to their network administrator. They look into logs and all those places, and they figure out what caused the issue, and then root cause the problem before a fix can be identified. But that is a very cumbersome process, and that takes a few hours to few days, depending on the problem. Whereas with the packet drop monitoring enabled by this MOD feature, a report, whenever a packet gets dropped, a report goes out to the collector immediately. The report will have the 5-tuple information so that the user knows what are the source and destination, and what is application for which the packets got dropped, and also along with the drop reason, why the packet dropped. And that will enable the operator to come up with a dashboard that is very useful for users, and also it will help root cause the issue very quickly, because it is all happening proactively in real time. So this is the use case that we are enabling here, and there are two different ways that this packet drop monitoring can be supported. One way is whenever a drop happens, a report goes out to the collector. That is all good, but then if let's say you are encountering some VLAN translation error and a lot of packets are getting dropped, then the collector may be bombarded with too many packets. So we built some kind of state mechanism within the silicon, so that the first a report goes out immediately when a first dropped packet was observed, and then the subsequent reports are suppressed. So there is deduplication happening within the silicon, so that the network is not bombarded, or the collector is not bombarded with a duplicate reports. And whenever the user can configure an interval, let's say 5 seconds, and if no packets are dropped for 5 seconds for the same drop reason, then it is considered the drops have stopped, and a notification goes out to the collector. And that means the collector is getting in real time the exact information why the packets dropped, who got affected, without necessarily bombarding the collector and network. So this is the use case that we have supported in SONiC, and we are innovating with every silicon and with every release. It was supported initially on Trident 3 silicon. In fact, we enabled it after the silicon was released. Now, and we supported whatever drop reason we could on that silicon, and now we are taking it as part of the silicon design and increasing the coverage for various drop reasons that can happen in the silicon. Also, we are more number of drops also being captured. So if you compare with the first release that we made, we almost increased the drop reasons by 10x with our newest and greatest silicon Tomahawk 5. All this is good, but you need to have a collector that can receive these reports and then correlate with the user application and make sure this can be consumed easily, right? And that can only happen if you have the support on the collector side. So that's why we are working with our ecosystem partners, where the support is widely available, because different customers may prefer different solutions, right? Like, so we have Broadcom has our own commercial network monitoring solution called DX NetOps, so that supports this packet drops. And we are also working with a few vendors such as Octera that already supports MOD today, and we also realize that some customers probably are looking for some open source option. And that is why we spent our engineering cycles to come up with the plugins and mechanism so that this can be integrated as an open source solution. And that's what we are going to focus now. My colleague Kamran will go into the details, what we have done and how the packet drops will be captured on the collector side and displayed to the user. Kamran?
Bhaskar, hopefully everybody can hear me now. So this is Kamran Naqvi. I'm a principal architect at Broadcom based in the UK. So on this slide, if you look in the middle, this big box in the middle is a graphical representation of our open source collector server that Bhaskar was talking about. So as you can see, this collector server, it composed of 4 components. And all of these are based on open source softwares. So we're using Grafana for visualization. We are using InfluxDB as our database as storage. And we are using Telegraph as our data collector agent. If you look on Influx data website for Telegraph, you will see there are 181 input plugins available for Telegraph. And they range from various components like AWS compatibility components, Azure input plugins, Cisco GNMI input plugins, and so on. What we have done is we have created an input plugin for Telegraph, and this input plugin allows Telegraph to decode mod messages and understand all the various metrics provided. This 4th box that you see at the bottom of the screen, this packet receive app, it is basically that input plugin. We have also enhanced the output plugin for Telegraph. So instead of just doing a metric write operation with our enhancement, now Telegraph can do this metric read operation, metric update operation, and metric delete operation. We're not doing much with InfluxDB. Didn't make a lot of changes. No soft code was added to InfluxDB. We're just using it to create our tables to update the metrics there. For Grafana, we added a new dashboard that we will show you in a minute. On the left-hand side, I'm showing the lab topology I have. This will be a live demo, and I've got these switches based on Broadcom Silicon and running Enterprise SONiC. On the right-hand side, I'm showing that any operator can access this Grafana dashboard using HTTP access. Let's move to the next slide. This is the configuration that I have on my SONiC switch. So I'm not going to go in detail of all the commands, but I would like to highlight a couple of those. So for example, the 4th command that you see here on this slide, flow group lab flow 4, this is probably the most important command here because this is how you can tell your switch, you can tell your mod feature what is the interesting traffic. So as Bhaskar said, that mod will create an alarm, will send this message if a packet drop happens, but mod will only do it for the interesting traffic, the traffic that tells that you tell this feature to look for. Let me give you an example. So for example, one of our customer at the moment based in Slovakia, they are building a HPC environment. They're building a supercomputer for Slovakian government. And in their HPC environment, which will be based on all open compute hardware and Enterprise SONiC, they are going to use IP storage. And obviously for IP storage, it is a very important, very drop sensitive traffic. It has to be lossless. So for that type of traffic, what they're going to do is they're going to monitor it using mod. If any packet drop happens, before your end users start complaining about it, your operations team will know that this particular flow is having an issue and they can do something to fix it. And with these remarks, let's move to the live demo. So maybe if you can stop sharing, Bhaskar, it will allow me to share my screen. Yes, okay, so there we go. Can everybody see my screen?
Yes.
Yes.
Perfect. Awesome. Okay. So this is the dashboard I was talking about. So as you can see on the right-hand side, this graphic will show the total number of active drops. At the moment, there are 0. This graphic in the middle, this component will show how many switches are reporting drops. On this top left-hand side, this graphic will show what is the drop anomaly percentage in your network. So drop anomaly percentage is basically how many drops you are saying, how many drops you are facing compared to your network baseline. And your baseline is the number of drops that you see over a defined period of time. So you can choose what is your baseline. You can have a baseline of maybe 5 years or 3 months or something like that. You can choose it. It's very flexible. So this value will help you understand how big an issue you are facing. So for example, if there is a network where some drops happen all the time, then maybe 1 or 2 drops will not be a big issue for them. But if there is a network where usually you don't see any drop at all, then even 1 drop will be a big issue and an alarm should be visible. This parameter will show you that. So now without further ado, let me start sending some traffic. So I have a server here, where I'm running some traffic generation software. What I'm going to send here is, I will be sending some traffic where source IP address will be equal to destination IP address. And as I'm sure all of us know, this is a well-known definition of a DOS attack. So when this packet will reach our switch, the switch will identify it as a malicious packet and will drop it. And with my configuration on the switch, this type of flow, this destination IP, I have defined this traffic as interesting traffic. So as soon as a drop happens in that flow, because it is an interesting traffic, mod will generate an alarm and our collector, this open source collector, will show us that the flow is being dropped. So I've generated the traffic and there you go. Now we can see that one drop is happening. It is reported by one switch. And here you can see the switch ID. You can see the 5 tuples. You can see what is the source of the address, what is the destination of the address. You can see the port numbers. So you can see even before any end users start complaining about the issue, your operations team have a very detailed information about the problem. And with this set of information, where we are even telling the reason of the issue, reason of the drop, your operations team will be equipped with a lot of very relevant information to go and fix it. And that is how we were saying, this type of feature can help you reduce your root cause analysis time from days or weeks to even hours or minutes. Let me send one more flow, and then we will wrap it up. So my second flow definition is even more interesting. So what I'm doing here is, my second flow is basically a flow which is defined as interesting, but it is being sent to a VLAN which is not configured on the switch. So it is a missing VLAN. In other words, I am simulating an issue where there is some configuration issue. Somebody forgot to configure something. Happens all the time. And in this case, as soon as we send that traffic, it is going with a certain VLAN number which is not configured on the switch. Switch is dropping it, and we can see an alarm here. And once again, as you can see, you know who is sending this traffic. You can see who this traffic is being sent to, who are the destination, and you know exactly where this drop is happening. So you may have a network of 1,000 switches. In this case, you know exactly which switch is dropping the traffic and then exactly why that traffic is being dropped. So very granular information for operations team to go and very quickly troubleshoot it. If I stop these flows, if I stop these, if I stop these flows, you will see that these matrix will go away. So I'll do. So for example, if I stop one of these, you will see that there you go. So it's now we can only see one, very obvious. So now all the active drops will disappear, but still you can see in this dashboard in Grafana, you have the historical information. So even if something is reported later on, or forensic analysis, you want to go back and check, you can go back and see what flows were impacted, on which switch they were impacted, when a drop started happening, when it stopped, and exactly what was the reason for those issues. So with these remarks, I will end my discussion. And if there are any questions, please let us know.
Kamran, sorry, a quick observation, please. Is this in any way similar to in-band network telemetry, or how different it is from this?
So in-band telemetry is different from MOD. In-band telemetry, there are several use cases, right? Where one use case is you want to do pervasive monitoring, right? Where you, for example, HPCC++ use case that tries to optimize the network with a minimal queue depth for rocky networks. They use this IFA, in-band telemetry, to continuously monitor the network paths for queue depth and then adjust the traffic load dynamically so that the queue buildup doesn't happen. If the queues are become emptier, they increase the traffic load or the flow rate, and if the queues are becoming busy, they will reduce the flow rate. So that is just one use case of IFA. No packets dropped here, but we are just monitoring proactively the network condition and then adjusting the RDMA workload. And there could be several other reasons, right? Like let's say you have a network operator that has to offer some kind of SLA, especially if you're a public cloud, you need to give some SLAs to the customers and then provide details saying, hey, I met the SLA that I offered to you. And that means they have to continuously monitor those metrics, and that is also that can be done with IFA at a very, very high scale without causing or without killing the network or the switch. Whereas MOD, it can be completely reactive. I mean, it's not necessarily reactive in the sense you are waiting till the user complained it, right? You are waiting only till the packet gets dropped. If, let's say you have a very great day and there is no packet drop happening, no alarm will go out, right? No packet generated from the switch, no packet received by the collector. So that's a very beautiful solution where you are keeping an eye without consuming network resources. So that's the difference between MOD and I hope I explained it. If you have a question, I can clarify.
No, thanks. Thanks a lot. I think we should connect, Bhaskar, if possible.
Sure, yeah.
Thanks.
Hey, very nice talk. This is Jeetu Upadhyay from Microsoft. I'm just trying to understand the semantics. The idea is that any packet that is dropped will be mirrored, or any packet that is dropped and then matches some sort of ACL that you have specified will be mirrored. And based on your answer, I have additional kind of follow-up question.
Kamran, you want to take that question? Whether that is
yeah, absolutely. So as you can imagine, packet drops happen in the network all the time, right? So we want to make sure that we are only alerted about the drops which are important. So that is why you have a very granular way of defining the flows which are interesting for you. And only if the drop happens in those flows, you will be alerted.
Yeah.
And then,
so it is, the packets are like, I mean, we have internal mechanisms. The ACL rules are used for, just like Kamran showed the configuration, it identifies what flows of interest that you want to monitor for drops. That is like more like ACL configuration. And then when the drop happens, it is, I'm not sure if it is copied to CPU. Are you asking, is it copied to CPU or the mirror to CPU? Is that the question that you're asking?
no, sorry. Okay. So if there's if I have a way to define the flow of interest or some sort of property of the packet that is of interest, and then you mirror it, then that's great. And I understand it's mirrored, right? It's not copied to the CPU. Okay. A quick follow-up question on that: will this apply both for ingress and egress drops, or only egress drops, or anywhere in the pipeline?
So that is where I mentioned in my presentation, right? When we started first with Trident 3 silicon, we enabled it after the silicon was released, right? So there is that's why we could only enable it for a limited pipeline stages. So there it supports ingress. But if you take our Trident 4 silicon, then it can provide you visibility into ingress, MMU, and egress. I mean, obviously, going forward, you should be able to have the drops observed at any stage of the pipeline. Only legacy silicon may have some limitations.
Okay, great. We'll love to learn more at some point. Thanks.
Yeah, thanks. This is Ying from Microsoft. I have follow-up question after Jitu's question. It's great questions. Thanks for the answer. So there are some corner cases that haunted us more, like, for instance, if we have some special package with some special patterns comes in and get dropped because of whatever reasons of whatever checks that ingress pipeline does, will we have in the capability in the future that we can also capture those packets and have a look at them? Thank you.
Sure, yeah, that'll be an interesting use case that we can support. Yeah.
Okay, sorry, let's take answer. Is that a yes? Sorry, I didn't hear the answer. Is that a yes or?
So yeah, again, depending on the suite system that you're talking about, if it is Trident 3, or generally ingress pipeline drops, yes, we can support. So if you can identify that traffic and then that silicon is enabled for MOD, we will be able to support that. Yes.
Okay, thanks.
Okay. One last question. We are eating our lunch time, but I guess that we prefer discussing than eating.
Hi. So I have one question about the handling the metrics part. So basically, how do we handle like the large volume of the traffic? The package job caused by those things, like for example DDoS or amplification attacks. So those things, if we mirror the packet on the job, essentially we probably can create a hole that can allow the attacker actually attacks our monitoring system, which eventually attacks the control plane systems, that will attack the system in another way. So wondering, is there any like mechanisms to avoid this thing to happen? Not sure if I explained my question clearly.
Yeah, sorry, I did not follow. Kamran, did you follow the question?
No, I'm sorry. Yeah, I think the question is about if there is an attack, there is a lot of traffic coming into control plane, but I missed after that.
Oh yeah. So basically, the packet jobs then caused by for example DDoS. Then there will be a lot of packet that gets mirrored, sent to the collector, and then attacks the monitoring system.
Okay.
And eventually, if the monitoring system is deployed with a control plane, network control plane, then it probably can create a chance to attack the control plane. So I'm wondering, is there any mechanism to avoid this thing to happen?
Yeah.
Yeah, good question, right? So there are two cases there, right? Like if you don't use stateful mirror packet drop monitoring, then yes, all the drops are going to the collector. There you could apply a rate limiter so that not every drop is going and you are applying some kind of rate. But the implementation that we have on SONiC today has a stateful drop monitoring, where I explained we suppress all the duplicate packet drops. So that means it is essentially the report going out on the first drop and then a later notification when the drop stops. So that way we are taking care of the situation or scenario that you mentioned.
So let's take it offline. Yeah. Let's give time to Miro Slav.
Okay.
Yeah, for open day night. Thank you, Bhaskar. Yeah, thank you, Broadcom.
Thank you. Thanks, everyone. Appreciate it.
Thank you, everybody.
Thanks.
Enjoy your lunch. Cheers.